When a port appears to be blocked, the natural instinct is to start randomly changing settings, opening ports in the firewall, restarting services, trying different things until something works. This approach is slow, dangerous, and causes more problems than it solves. The systematic approach: treat a blocked port as a diagnostic puzzle. Every layer of your stack has a way to tell you exactly what it's doing. Your job is to query each layer in order and let the system tell you where the failure is. The investigation chain has 5 layers, and you work through them in order: the internet path, the cloud security group, the server firewall, the service listening state, and the application itself. Before you change anything, gather information. Before you open a firewall port, confirm the firewall is actually the problem. Before you restart a service, confirm the service is actually down. The golden rule: never change 2 things at once. If you open a firewall port and restart a service simultaneously and it starts working, you don't know which change fixed it. The problem will reappear because you didn't understand the root cause. This module gives you a repeatable debugging framework that takes the guesswork out of blocked ports. You'll be able to diagnose any port issue in under 5 minutes. Every port is blocked issue lives in exactly one of 5 layers. Your debugging process is to test each layer in order until you find the broken one. Layer 1: path to server. Can you reach the server at all? Can you ping it? Can you SSH? If you can't even SSH, the problem is either the cloud security group or a network outage, not your application. Layer 2: cloud security group. Is the port open in the cloud provider's console? This is an external firewall that operates before traffic reaches your server. Check the actual console, not your memory of what you configured. Layer 3: server firewall. Is the port allowed in firewall? Run firewall cmd list all and confirm the service or port is listed. If you're using iptables directly, check iptables L. Layer 4: service listening. Is the application actually listening on that port? A port can be open in the firewall but still not work if nothing is listening. Check with sstlnp or netstat-tlnp. Layer 5: application itself. Is the application running and handling requests correctly? It might be listening but returning errors. Check application logs and test with curl from localhost. The key insight: each layer is independently testable. You can confirm layer 3 is fine even if layer 5 is broken. Work from the outside in and stop as soon as you find the broken layer. Before diagnosing firewalls, verify basic network connectivity. These tools tell you where packets are being blocked. From your local machine to the server, testing if traffic reaches the server at all. Ping server_IP tests basic IP connectivity. If ping fails, either ICMP is blocked, common, or the server is unreachable. Ping success doesn't mean ports are open. Telnet server_IP port connects to a specific port. Connected means the port is reachable. Connection refused means the server is rejecting the connection, port might be closed or firewall rejecting. Connection timed out means the firewall is silently dropping the packet. NC ZV server_IP port, NC netcat, with Z, 0 IO mode, and V, verbose, tests whether a port is open. Succeeded means reachable. More reliable than Telnet for scripting. Curl the http://server_IP port, tests HTTP connectivity. Shows detailed connection information including DNS resolution, TCP connection, and HTTP response. Most useful for HTTP/HTTPS ports. Map port server_IP, scans specific ports. Shows open, reachable, closed, server refused, or filtered, firewall dropping silently. Requires map installation, sudo apt install map. The distinction between refused and filtered is crucial. Refused means the packet reached the server but nothing accepted it. Filtered means a firewall dropped it before anything could respond. This tells you whether the problem is the firewall or the application. The cloud security group is the outermost layer. If it's blocking traffic, nothing on your server matters, you'll never see the packets. Signs the cloud security group is the problem: connection times out, not refused. The connection appears to hang and eventually times out. Filtered in map output. This is characteristic of packets being silently dropped by an external firewall. Signs the cloud security group is not the problem: connection refused. If you get an immediate connection refused response, the packet reached the server. The cloud security group allowed it through. To check, log into your cloud provider's console, AWS, Oracle Cloud, Azure, GCP. Navigate to your instance's security settings. Look for inbound rules. Verify the port is listed with the right protocol, TCP versus UDP. Common cloud security group mistakes: wrong port number, you open 3006 instead of 3000. Double-check digit by digit. Wrong protocol, you open UDP but the service needs TCP. Most web traffic is TCP. Wrong source, you restricted access to your office IP but you're working from home. Check what your current public IP is, curl if config.me. CIDR notation error, 0.0.0.0/0 means all IPs. 192.168.1.0/24 is a specific range. If you see 192.168.1.1/32 when you meant to allow all traffic, that's the issue. After verifying the cloud security group is correct, move to layer 3. Once you've confirmed the cloud security group allows the port, verify the server level firewall. Check firewall status and configuration, sudo firewall cmd state should output running. If it outputs not running, the firewall daemon is down. Traffic may or may not be blocked depending on underlying iptables rules. Sudo firewall cmd list all, this is your primary inspection command. Look at services, name services allowed, ports, specific port numbers allowed, rich rules, advanced rules. If the port isn't listed, add it. Sudo firewall cmd permanent add port equals port/tcp and in sudo firewall cmd reload. Then retest connectivity. If the port is listed in traffic still doesn't get through, the problem is in a different layer. Don't make more firewall changes, move to checking the application. Check iptables directly for unexpected rules, sudo iptables ln egrep port, look for drop or reject rules that mention your port. Sudo iptables tnat ln, check the NAT table for any unexpected redirect or DNAT rules that might be intercepting your traffic. Verify firewall zone assignment, sudo firewall cmd get active zones, confirms which interface is in which zone. Your main network interface should be in public. If it's in block or drop, all incoming traffic is blocked. A port being open in the firewall doesn't mean anything is listening on that port. If nothing is listening, connections will be refused. The command to check what's listening, sudo tlnp, shows all TCP sockets in listening state. The output columns are state, rec queue, send queue, local address, port, peer address, process. Look at the local address column. If you see 0.0.0.0:3000 or :3000, the service is listening on all interfaces on port 3000. If you see 127.0.0.1:3000, it's only listening on localhost. External connections will be refused even if the firewall is open. If you see nothing for your port, the service isn't running. Start it. If you see 127.0.0.1:3000 but expected external access, the service is bound to localhost only. This is actually correct for a Node.js app behind Jinx. Jinx accesses it via localhost. If you're trying to expose it directly, you need to change the application's bind address. Sudo netstat tlnp, alternative to SS, works the same way. Some systems have netstat, others have SS install nettools for netstat, sudo apt install nettools. Checking if a specific process is listening, sudo sstrlnp egrep node shows only sockets held by Node.js processes. Sudo sofai 3000 shows all processes with a file descriptor open on port 3000. The most detailed view of port usage. Always test from localhost first. If the application works on localhost but not externally, the problem is the network path or firewall, not the application. This isolation technique saves enormous time. Test from localhost, SSH'd into the server curl http://localhost 3000 tests if Node.js is responding. If this works, Node.js is running and handling requests. Curl http://localhost 80 tests if Jinx is responding. If this works, Jinx is running. Curl http://localhost 80 tests HTTP response headers. Useful for checking if proxy_pass is working. If localhost works but external doesn't, the problem is between the internet and the server. Check firewall layers. If localhost doesn't work, the problem is the application itself. Check application logs. Common application level failures, Node.js process crashed, PM2 status shows stopped or errored. Check logs, PM2 logs lines 50. Wrong port application bound to port 3001 but Jinx is proxying to 3000. Check your ecosystem.config.js and Jinx proxy_passport. Application boot error, PM2 shows online but the app crashed after startup. Check PM2 logs for stack traces. The localhost test is your firewall bypass. Traffic to localhost uses the loopback interface, which bypasses firewall's public zone. If it works locally, the application is fine and the firewall is the issue. When Jinx is in the stack, blocked ports often involve Jinx configuration errors, not just firewall issues. Test Nginx configuration, sudo nginx t. This validates the config file syntax. If it fails, Nginx won't serve any traffic. Fix syntax errors first. Check Nginx error log, sudo tailf/var/log/nginx/error.log. This shows connection errors between Nginx and upstream node.js, configuration warnings, and SSL errors. Common Nginx errors and what they mean: 502 bad gateway, Nginx can't reach your node.js backend. Causes: node.js is down, PM2 shows stopped, wrong port in proxy_pass, proxying to 3001 when app runs on 3000, node.js crashed at startup. 504 gateway timeout, Nginx reached node.js but the request took too long. Node.js is alive but overwhelmed or stuck processing. Connection refused at proxy level, sudo curl http //localhost 3000 from the server. Does it work? If not, node.js isn't listening on port 3000. Checking what port proxy_pass is using, cat/etc/nginx/sites enabled/yoursite. Look at the proxy_pass line. Confirm the port matches where node.js is actually listening. Testing the full Nginx to node.js chain from outside, curl http://server_ip. Check the response headers. Look for server Nginx header. If you see it, traffic reached Nginx. If you get a timeout, Nginx isn't receiving the request. Curl https://yourdomain.com. Test the full HTTPS path. Here is the complete, ordered checklist. When a port appears blocked, run through this list in order. Stop when you find the issue. Step 1: Identify the symptom: connection timeout, silent drop, or connection refused, port reached server but rejected. Step 2: Test SSH. Can you still SSH in? If not, check Cloud Security Group for port 22. Step 3: Test from outside using map or telnet. Is the port open, closed, or filtered? Step 4: Check Cloud Security Group, log into Cloud Console, verify port, protocol, and source IP range. Step 5: Check firewalld, sudo firewall cmd list all. Is the service/port in the list? Check active zone. Step 6: Check iptables for unexpected rules, sudo iptables ln and grep port. Check NAT table 2. Step 7: Check service listening, sudo sstlnp grep port. Is it listening? On 0.0.0.0 or 127.0.0.1? Step 8: Test from localhost, curl http://localhost port. Does it work? Step 9: Check application logs, PM2 logs, journal /var/log/nginx/error.log. Step 10: Test Nginx config, sudo nginx t. Following this checklist in order takes 5 to 10 minutes and identifies 99% of port issues. Don't skip ahead to step 5 because you assume it's the firewall. Check in order. A realistic debugging scenario to apply the framework. Your node.js application runs on port 3000. Nginx proxies to it on port 80. Users report the site is down. From your local machine, running nczv server_ip80 produces connection refused almost immediately. You SSH into the server and run curl http://localhost 80. It succeeds and returns your app's HTML. What is the most likely cause? Option A: the Cloud Security Group is blocking port 80. Connection refused means the packet reached the server and was actively rejected, not silently dropped. If the Cloud Security Group was blocking it, you'd get a timeout, not an immediate refusal. Option B: firewalld is blocking port 80. Same reasoning, firewalld's drop policy causes timeouts. An ICMP rejection from firewalld might cause refused, but if localhost works from inside the server, Nginx is running and listening. Option C: Nginx is not running. If Nginx weren't running, curl http://localhost 80 from the server would also fail. Since localhost works, Nginx is up and handling requests. The problem is between the external network and the server's public interface. Option D: the connection is hitting Nginx on localhost, loopback interface, but the public interface has a different listener configuration. Possible but unlikely. Nginx typically binds to all interfaces. The answer is, look more carefully. Since localhost works but external connections fail, the most likely cause is that Nginx is listening only on 127.0.0.1, localhost, instead of 0.0.0.0, all interfaces. Check, sudo sstlnp grep80. If you see 127.0.0.1:80, change the Nginx listen directive from listen 127.0.0.1:80 to listen 80.